Hello everyone, in this video we are just going to interface SW420 analog vibration sensor to our ESP8266 development board or Node MCU by developing relevant Python scripts on thonny IDE. Let's get started. So this is the thonny IDE. I'm just going to create a new project or file. Just click on this particular icon or Ctrl N in your keyboard for creating the new file, and I'm just going to save this by clicking on Ctrl+S. This computer, move to the relevant folder where you want the scripts to be saved. I'm just going to the location where my Python scripts needs to be saved, and I'm going to give it as SW420_analog. When you save, you can clearly see it is saved in .py Python format. Just cross verify this, and that's it. Now let's start writing our Python scripts for interfacing SW420 with our Node MCU. Before that, let's discuss in detail about the layout schematic that we are going to build for interfacing this particular analog sensor with our Node MCU or ESP8266. So let's discuss in detail about the schematic that we are going to build for interfacing this particular SW420 as analog sensor to our ESP8266 or to our Node MCU. So as discussed in previous one of our video, we just interface the same sensor SW420 in digital format, but in this video we are just going to interface the same sensor in analog sensor type. So the change is very simple. We are just going to utilize the analog output from the sensor instead of digital. We will be neglecting that DO, that is digital output pin, and we will be utilizing analog output pin data. This VCC and ground is useful for powering up this particular SW420 vibration sensor module. So I will be powering up the vibration sensor from the power source of Node MCU itself. So I am just going to connect Vin to VCC for powering up the SW420, and ground I am just going to connect it to ground of Node MCU, and further I am just going to neglect this digital output pin since we are just going to interface this SW420 vibration sensor module in analog sensor type format. So I am just going to utilize this particular AO, that is analog output pin, for fetching the ADC output data from the sensor. So I will be connecting this particular AO, that is analog output, to the analog ADC input pin A0 right over here in the external connector. So this is the circuit that I am going to build, and using this particular USB connector I am just going to power up the Node MCU. I am just going to flash the program also right over here in this Node MCU using this micro USB connector by connecting this particular connector to the PC USB port using micro USB cable, and this will power up the Node MCU, and Node MCU itself will power up this particular SW420 module. Since this consumes very less amount of current, I am just doing this. If you are connecting 4 or 5 sensors like this, you just want to connect or use an external power source for powering up the sensor modules. So that's all about the schematic diagram that I am going to build in my breadboard for interfacing this particular SW420 vibration sensor to my Node MCU or ESP8266 development board. We are just going to make only 3 connections: VCC ground for powering up the SW420 vibration sensor module, and analog output from the SW420 vibration sensor we are just going to connect it to A0 of Node MCU for fetching the analog voltage signals in our ADC module of our ESP8266, that is this one. So that's it. Let's continue. So now we got to know that we have a A0 analog pin to which we are just going to connect output or analog output from SW420 vibration sensor. So as per our schematic we discussed this, we are just going to connect the analog output from the SW420 vibration sensor to our A0, that is analog pin 0 of our node MCU or ESP8266 development board. So as the first step, I am just going to import missing, and from missing I am just going to import ADC library for using the ADC relevant APIs. Regarding the ADC and basic functionality of this ADC module, that is analog to digital converter module inside a microcontroller, I have done a separate video. That video you can find in the description of this particular video, or in the playlist of this series. You can find that video just before this video. I hope if you are interested in knowing about what is ADC and the basic functionality of successive approximation method that it uses for approximating the values that is fetched through ADC module, you can go back to that video and you can learn in detail about that. For now, we will continue this particular video, and after that I am just going to import uTime for using delays in my program. And as a first step, I am just going to declare and define a function, a variable ADC, and I am going to assign the ADC variable with the ADC channel ADC of 0. So we have configured the ADC 0 or enabled the ADC conversion in our channel 0 of node MCU, and we have defined that to a variable ADC, or we will name it as SW420, and I am just going to use a infinite loop while of true, and inside the infinite loop I am just going to get the value of the ADC that I am receiving through this SW420. So we have attached the SW420 analog output pin to analog channel 0 of node MCU. So we have defined a variable called SW420 and we configured and enabled the ADC conversion in our channel 0 of node MCU using this particular line. So here I am just going to use another variable called ADC value, and I am going to read the value from SW420. So for that you can use the API SW420.read. And following that I am just going to give a delay of 200 milliseconds after that. So inside this while true, that is while loop, that is infinite loop, I am just going to write two lines. One is reading of ADC and storing that to a variable called ADC value, and following that I am waiting here for 200 milliseconds. As soon as we read, I am just going to visualize the output in my cell right over here. That is below here we have a Python cell. In that cell I am just going to print the ADC value. So SW420 ADC value, I am just going to print the ADC value. That's it. We are reading the values and we are printing onto the cell, and we are waiting here for 200 milliseconds. So this process continues until the program is stopped in this particular cell. And just remember, we are having a 10-bit ADC in ESP8266, meaning we will be having ADC values between 0 to 2 to the power 10, that is 1023. So our minimum ADC value, step value will be 0 and maximum value will be 1023. Let's assume we are having, or we are just going to give a maximum voltage of 5 volts to this particular ADC pin. So 0 volts on the pin will fetch us the step value of 0, and 5 volts at that particular ADC pin will fetch us the step value of 1023, and intermediate values will be calculated based on this particular resolution of ADC. If we have a 12-bit ADC, the values will differ between 0 to 2 to the power 12, that is 4095. Since we are having a 10-bit, we will be having values between 0 to 1023. That's it. I'm just saving the script and I'm going to and I am going to run this particular program in my node MC, which I have already connected, and I have already built the schematic that I explained to you before in my breadboard. You can see in my cell I am getting values, that is minimum values 2, 3, 1, etc. And this is the vibration sensor. You can clearly see this is the vibration sensor. When I try to shake or create a vibration in the sensor, you can see I am getting intermediate values or maximum values sometimes. Based on the vibration that I am getting in my vibration sensor, the ADC values changes. So for maximum vibration I am getting 1024, and intermediate vibrations I am getting the respective values. And as I mentioned, we are having 10-bit ADC, so it is not exceeding value of 1024. So this is how you can interface any analog type sensor to ESP8266 using the analog channel available in that node MCU, that is A0. And I hope you learned something new by interfacing vibration sensor analog output to the ESP8266 analog input, and we used the internal ADC of node MCU or ESP8266 SoC for calculating the step value by providing DC input in the analog channel of ESP8266. See you in the next video. Thanks for watching.